Hello. So in this lab, we'll be investigating the phenomenon that occurs when you charge two tapes and put them against each other. So we'll be modeling the combination of electric and gravitational forces which act on tape. The experiment will measure the force of repulsion between the two charged tape strips, and we'll discuss them and how they operate. Because as a base, we'll use the electric laws, such as Faraday's and Coulomb's, in order to explain the phenomenon, and a model where the force of repulsion is balanced with the force of gravity is made through glow script to measure the electric force. First off, it's clear to build the foundation on which the experiment's reasoning is based on. So we have two formulas, Coulomb's law and Faraday's law, which ultimately work to create the way how the electric force is created. We have the electric field, which operates on a single charge, and then how that electric field acts on another charge. And so also Newton's second law comes into play while measuring the force and gravity on the tape. So the lab is set up where you have one tape on top and one on the bottom. The first tape is held up by two objects, and the second one is used as part of the surroundings to act upon the top tape, which acts as the system. So the two have a distance of 0.015 meters when the top tape is completely balanced so that it no longer sags, but instead it's at equilibrium, meaning that the force of repulsion must be equal to the force of gravity. When ripped off the non-sticky end of another tape laid on a smooth surface, a strip of tape attracts to positively and neutrally charged objects. When brought near another such charged strip, the two repel each other. This obviously means that both are negatively charged. And so the model goes to represent this. The model goes off of certain assumptions, such as air resistance being completely ignored. The top tape is also act as a point charge, with all the charge being at the center, and the other tape has the same amount of charge, which is evenly distributed along the tape. And so the force of gravity and the force of repulsion found by the model is the given number here, 0.002107 newtons, and the excess amount of electrons and the number of atoms and the ratio of excess electrons to the number of atoms is that. And I'll show that these are values given by my model for the experiment. Here's the code for the model. Here we have the tape 1 and tape 2, the constants which involve the experiment, the two arrows which represent the forces. And so the charge of the tape, the top tape being that, is found using this equation in which we derive it from making the force of gravity and the force of the electron equal. And so with that, we can find the amount of excess electrons by dividing the overall charge by the average charge of an electron, which is the same as a proton, and find the number of atoms by dividing the distance by the average length of atoms, and then the ratio being just dividing the excess at e to the atoms. And so when the code is run, we have a model which depicts what's occurring. This point charge represents the other tape, which is part of the surroundings, which puts this electric force onto this charge. And then there's the force of gravity, which the Earth being also part of the surroundings, forces the gravitational pull. And as you see, both of the arrows are equal in magnitude, meaning that this point charge is in equilibrium. And so with that said, it's time to talk about some of the things which, if we were to manipulate some of the things which occurred. So if instead of there being excess electrons, you instead have excess electrons with positive charge and the protons being negative, really what that would do would ultimately not change too much, because the charges would be redistributed along the surfaces accordingly as they would if there were negative charges on the surfaces. And now excess electrons with positive charge are going to repel against the positive electrons of the other tape. Therefore, the force of repulsion is ultimately going to be of the same magnitude and be on the same direction against the top tape. Now, when handling the tape, it's good to make sure that our hands and other objects don't interact with the tape, which is charged, and this is because of the grounding effect, basically meaning that excess charge on the tape transfers to our hands and these other objects instead of acting against the other tapes. So contact should be limited in order for this excess charge to not act against the other tape and manipulate the data. So that's it.